Hello everyone, I'm Vishal from Edureka and today I'm going to talk about SAS. SAS is one of the prominent tools in the analytical market. It is a software suite with various analytical and graphical capabilities. But before we get started with SAS, let's quickly take a look at today's agenda. I would be starting things off with data analytics and different data analytical tools. The fact that SAS is a data analytical tool, I feel it is important we understand what is data analytics first. Once we've understood data analytics, then we can move towards SAS. In SAS, I would be talking about why it is needed and what it is. I would discuss SAS's framework. Once we are done with this, then I would get into the programming part. I would introduce you to SAS's programming concepts and I would give you a few examples so you understand the programming part better. And finally, I would finish things off with SAS applications. So this is our today's agenda. Let us get started with the first topic of discussion, that is data analytics. Well, this term has been trending in market for quite a while now. Many businesses and individuals use it, and using data analytics they solve different kinds of problems. But still, people and businesses have this question as in why analytics? Why is it so popular? Why do so many people and businesses use it? What kind of problems do they solve using data analytics? Well, to answer these questions, let us consider these 3 points. What data analytics does is, it helps you achieve these 3 goals, that is cost reduction, better decision making, and improved services. Let me give you an example. Reliance Telecom Services in India launched a new SIM card called as Reliance Jio. What this did is, they gave away some free internet services and calling services to people for 6 months. Now this resulted in a lot of people switching from the existing networks to Reliance. Hence this was a great boon for Reliance. Now how did they do it? They used data analytics. Using data analytics, they crunched the existing data they had. They found out patterns, that is what is required in the current market, and accordingly they took decisions. These decisions help them save a lot of cost and it also helps them improve their services. Now that is what analytics does. No matter what kind of business it is, it helps improve businesses by taking better decisions, by understanding that data better and finding out patterns which cannot be found out otherwise. So yes, that is why analytics is needed. Now let us move further and understand what it is exactly. Data analytics. Well, it is very simple. What data analytics does is, it takes in existing data. Nowadays there's a lot of digital data, but this data cannot be used for some reasons, for many other reasons actually. Say for example, businesses have data in different formats. They have different problem statements according to which data also varies. So this different data is difficult to understand. At times it is masked, at times there are missing values, at times it is not clean. There's so many problems with it. So what these people do is, they contact data analysts or scientists. Now these people basically organize the data into more understandable manner or more understandable format. They store it properly and then finally they mine it. When I say they mine it, they actually implement various algorithms and those algorithms help you understand the data better. You can target particular problem statements and accordingly you can generate data and try to find out information that can help you take better decisions. In short, we are taking data, converting it into knowledge which gives you clarity, which helps you take better decisions that surround your business. That is what data analytics is. Now that we've taken a look at what data analytics is, let us take a look at few important tools that are trending in the market. Now all these tools help you do data analytics. I've mentioned few popular ones only because there are a lot of tools, but we will be focusing on few important ones. Let me quickly walk you through these tools. What do these tools do? Say for example, we have R and Python. Now these are open source tools. These are statistical programming languages. Both have their different capabilities and both are very popular in the market. They are available freely so anybody can download it and start analyzing data. Then we have Excel. If you like the old traditional way of dealing with spreadsheets, you can always turn to Excel. It has various graphical capabilities and statistical calculation capabilities. Then you have other tools like Hive and Pig. These are big data tools. What Hive does is, it helps you deal with unstructured or structured data no matter what format it is in. It helps you analyze it, summarize it and find out patterns out of it. It has its own query language called as Hive query language. Then we have other tool called as Pig. Pig is mostly used for map reduce codes, writing map reduce codes. That is what it is very famous for. Now I won't get into the details as in what map reduce code is. In simple words, what it does is, it helps you form a template, I would say. Using that template you can crunch data or you can divide data into smaller parts and then process it to make sense out of it. So that was about Pig. We have Apache Spark, which is another open source tool. If you're looking for parallel computation, this is one of the best things you can use. It has high parallel computation capabilities. It is highly fault tolerant. And again, it's available freely, so anybody can download it and use it. All in all, a great tool. But then we come back to SaaS again. Now, all these qualities which we talked about, almost everything can be taken care by SaaS. Yes, it is a proprietary tool and companies have to pay a lot of money to get SaaS into their system. But yeah, it has so many good capabilities that makes it stand out or stand ahead of all the other tools I just talked about. Let us try and understand few of these capabilities which SaaS has, or why it stands out ahead of the other tools. Why SaaS? Well, I've jotted down few important qualities as in why SaaS is so good. There are many other qualities as well, but I thought these were few important ones. Say for example, ease of learning. Now SaaS is very easy to learn. It is very SQL-like, and anybody who has knowledge of SQL can easily pick it or start learning or understanding it. It's not that if you do not know SQL, you cannot learn it. You can still learn it. It is very easy to learn, but SQL does help. There are many components which just help you drag and drop components. So that way it helps you to minimize your work. You don't have to worry about the coding part either. You can just pick up the components you need and you use them directly. So yes, it's very easy to learn. Let me give you an example, an analogy. If you compare two operating systems, say Linux and Windows, now both are great and they have the different fan followers. But if you look at its GUI or ease of using, I would say that Windows beats Linux because it is very easy to use as far as the interface is concerned. Similarly, when it comes to programming, SAS leaves other tools far behind. It is way better or easy to learn as compared to R and Python. So that is one quality. The other one is graphical capabilities. Now, if you're analyzing data or you're dealing in data analytics, it is very important your tool has good graphical capabilities because there's so much visualization and understanding of data. So it is important that your tool gives you these facilities where you can take a look at data, you can visualize it, and SAS does exactly that. It has a component called as SAS graph. If combined with base SAS component, it just does wonders. The next point is advancement in tools. Now yes, SAS has been there in market for more than 50 years. So it follows a structure. No matter what kind of change comes in the market, say for example, there has to be some advancement in the existing tool. It takes time because a strong procedure is followed. But when those changes are made, they are very much up to the market and they beat almost every tool when these changes are incorporated. So yes, again, great advancement in tools. And finally, the job scenario scene. Now what happens is people normally turn to SaaS so they can get good jobs and they're not disappointed most of the times. The reason is simple. SaaS holds 70% of analytical job market. Now that is huge by huge margins. The second competitor SaaS is R, which is some 15% in the market and which is way less than 70% which SaaS has. So it's clear cut as in these are the qualities which makes SaaS stand out. There are other qualities as well. Say for example, SAS is a great reporting tool or an ETL tool. When it comes to data warehousing, you can do so many things using SAS. You can extract, you can transform, you can load your data the way you want to, you can manage it in different ways. So there are other capabilities which I haven't talked about, but all these capabilities makes SAS a very good tool. This was about why SAS. Let us try and understand what it is exactly. Well, to start with, it stands for Statistical Analytics System. As the name suggests, it is used for analytics, or that is what it was designed for. Now, there are many people who don't even use it for analytics. They do various other things using SAS, but that is one of the prominent features which SAS has. It is one of the best tools for analytics. So yes, it's a statistical analytical tool. It has its database management capabilities or data management capabilities. I talked about it being a great ETL tool. It has various extraction transformation capabilities as well, and its data management capabilities also make it very easy to use. Then it is also a great programming language, as in it is the fourth generation language. If I'm not wrong, SAS is the only analytical tool which is a fourth generation programming language. For people who do not know what fourth generation programming language is, it is nothing too difficult or different to understand. In simple words, these languages or these applications are designed to meet a particular goal. Say for example, if I have to develop a commercial software, I can use SAS, I can use some component or some application of SAS and I can develop that commercial tool which I'm planning to develop. And since I'm using SAS, what I'm doing is I'm using only those features that are required for developing that commercial tool. So it is more focused on the technology or the stuff that is to be developed. What this does is it helps reduce costs, it helps reduce time, and it also reduces the programming part. So that is where SAS stands out. It gives you almost everything. You can do analysis, you can develop applications, you can cater different needs. It has its own data management capabilities. All in all, it does almost everything. It is a complete software suite. So this was about what it is. Let us take a look at SAS's framework, as in what are the things that make SAS strong, or how does it internally become very strong, or what it does. Well, these four capabilities of SAS make it a strong contender in the market. One of those is its accessing capabilities, then its managing capabilities, the way it analyzes the data, and the way it presents it. So let us discuss the first point, which is accessing data. As I've already talked about, there's a lot of data in the market. If you take a look at the digital data that is there in the market, if you ask me how much is this data, well, if I write down this data in a book and if I stack these books on top of each other, the stack would be so long, or the distance would be so much, that it could actually travel from Sun to Pluto and come back again. Now you can imagine how much is this data. And this data is stored in different formats. And based on different businesses, the data is handled differently because it's meant for different problems. So this is where the businesses face problem. When it comes to accessing this data, they want a tool that would help them access data in any which way format it is in. That is what SAS helps you do. No matter what kind of format it is in, whether it's an Oracle file, whether it's a SAS database file, it is a raw database file, or your Excel file, it would help you access that data with ease. So that is why it is one of the important qualities or capabilities SAS has. The next one is managing data. I've already talked about it being a great ETL tool and all those things. But yes, it still has a lot of other capabilities. It has great management capabilities. It can help you subset data. It can help you merge it. It can help you create new variables, clean and validate data. Now you might say that many other tools also help me do this. How is SAS different? SAS is different with the ease with which you can do these things. It is very easy to implement all these things in SAS. You have well-defined libraries and procedures which make programming very, very easy. And doing these things as in subsetting data and creating variables are just one-step processes. You can implement complex algorithms by just single line of code. That is how easy it is to take data and manage it and store it properly. The next point is analyze or analysis. Now yes, SAS is a great statistical tool. It is a gold standard in the market to start with. The reason is you can do so many things as far as statistics or analysis is concerned. Whether you're talking about basic problems, dealing with frequency, central tendencies, that is mean calculation and all those things, even these things can be taken care of. Or if you're dealing with complex problems like regression, classification problems, decision trees, forecasting data, almost everything can be taken care by using SAS. It is one of the best tools as far as clinical research is concerned, and that is why it's very popular as far as forecasting is concerned. So yes, it has great analysis or analyzing capabilities as well. And the final point is presenting data. Now it becomes very important that you're able to present your data well. If you ask a data scientist, where does he put in most of his energy? He would say, the most difficult part which we start with is organizing data. 70% of the effort is put into it. Remaining 30% is distributed amongst other things. Now out of this 70%, most of the time again is spent in visualizing data. So if you can represent data in a good manner, it becomes easier to organize it. And once you're done with this 70% of the processing, the other 30% is given to analyzing data and finally presenting it to the business people. Now this is the toughest problem people have. Yes, as data scientists, we do understand data, but would the data be understood, or would the problem definition be understood by the business people? Now that is a different problem. So whatever these people understand, it needs to be communicated to the business people, and there is a large gap between these two phases. So it becomes very important that your tool is able to present the data in good manner, because this forms the bridge between the gap that is there. And SAS helps you do exactly that. It has great presentation capabilities. You can create any kinds of reports. You can generate list reports, summary reports. I've talked about its graphical capabilities. You can even print reports. Now while programming, we would be using SAS's University Edition. I've used this tool for quite a while now, and this is one of the easiest tools when it comes to giving outputs or printing data. So all these capabilities make SAS a great presentation tool as well. and all the capabilities which I talked in last 5 minutes. These form the SYSATEM core or its framework. I hope you've understood this. So this was about the SYSATEM concepts and analytics which we just talked about. Let us get into something more robust now, the SAS programming part. So what I would be doing now is, I would be introducing you to the SYSATEM programming concepts. And parallelly, I would also be walking you through with the codes as in how to implement those codes. Now to do that, I've used an environment called as SAS University Edition. It is available freely on SYSATEM's website. You can download it and you can install it. If you need any installation guidance, you can go through my blog. I've given its link below the video or above the comment section. You can refer that link and you can install this environment and you can start using it. If you already have some interface or environment, you can just follow the commands or the code which I'm going to do now. So let us get started with the first topic, that is SAS programming process. It is a very basic thing. I believe most of you know it already. What we do in SAS is we first define a problem statement, we write a code, we run it, and if there are any errors, we debug the code or modify it according to our need and re-implement it till we get our desired result or whatever it is. From now on, we are going to focus more on this part. This is where we are going to do the bulk of our talking, that is writing a SAS program. So let us try and understand SAS's programming structure first. Well, the programming structure of SAS is divided into two building blocks, your data steps and your proc steps. Data steps help you create data or data sets. You can add data to the existing data set. You can compute values of variables. You can manage data. Say for example, you have to do operations like subsetting or merging. These can be done using your data steps. Now once you have the data, you need to process it. And to process it, you use your other building block, that is proc steps, also known as the procedure steps. Now you have to process data in any way that can be taken care by using your proc steps. You can print your data, you print your outputs, you can analyze data the way you want to, you can create reports, you can do various visualization or graphical operations using your proc steps. So when it comes to creating data, your data steps, and when it comes to processing it, your proc steps. This is what forms the core of SAS programming. Every program would have a data step or a proc step or both. So this was about the programming structure. Now let us take a look at SAS's data and data types which it uses. Well, data in SAS is dealt in tabular form. Your variables would always occupy your column space and observations would take your row space. For example, name, your ID or whatever it is, these variables, they would lie in the column space and their subsequent values depending upon the records would lie in your observation or in your row space basically. So this is how the data looks. If you're talking about the data types, it has two data types, your numeric data type and your character data type. The numeric data type will have all the numbers and everything other than that would fall under your characters. So what if that data that is not understood or not classified by SAS under these two categories? How does SAS handle it? Well, to handle that kind of data, SAS uses two concepts called as in format and format. I would be talking about these things, and I would also be talking about one more thing called as SAS date, but I want to do it while doing the program so that you understand it better. So let us do one thing, let us switch to our environment or the interface and start coding first. So we can get to this part. Well, this is SAS's University Edition. This is how it looks and it is very easy to use interface for your base SAS coding. Almost all the code that is there in base SAS, everything can be done using your University Edition. Let me just tell you what all it does. Now this is your code window. You can write your codes here and you can run it here and here. You have this log window where you get all the warnings, errors and notes. The result window where the result is displayed. Now you have these icons. These are used to display your data or get a file from as an output. Say for example, I want to download an HTML file. I can use this icon. This is for the PDF file, Word or RTF file. I can plainly download it in whatever format it is already there using this thing. I can print it. I can minimize, maximize it. So it's an easy to use interface. Everything is available. All you have to do is type your code and run it. So let us create a data set. I would be using a data step. Let me tell you one more important thing. SAS is not case sensitive. You can enter data in any case, upper or lower. But I would suggest you follow some standard procedure because it would be easier for you to see and understand your codes when you've written lengthier codes in future. The more organized it is, more easier it is for you to understand. So let us get back and create a data set. I would be creating a data set called as employee info and I would be giving it input values. Say for example 3 variables. My first variable is employee underscore ID. It's a number so I don't have to worry about it. Next one is my character variable. So if you are creating a character variable, you have to make sure that the variable name follows a dollar sign, which indicates that it's a character variable. And my third variable again would be a character variable, and it would be called as vertical. So yes, I close it with semicolon and I give it some data lines as input. Say for example, I'm giving it 5 values about 5 employees with the verticals they work on. So these are the 4 people who are working on some particular technology. Given some random values to it, it's not very important. I just want a data set with 5 values. So not 5, I can have any values, but for the safer side, I've created 5 values. Let us say Ratish works on JavaScript. And finally, I have Rutuja, too many R's in it. She's working on maybe data science or something like that, say Python. Yes. So I close this with a semicolon and I run it to see what the data looks like. Now you have to select the code and you have to click on this icon where a little guy is running. You can always click on it and run the code. And this is how the output would look. Now this was about creating a data set. I used a data step. I created a data set called as employee with 3 variables and 5 values. Let us use a proc step and try to print this data. So I would be using a procedure called as proc print. I would be giving it the data set which we just created, and then I would run it again. Now the data is more visible, or it is more in printable format now. What I've done is I've just used a procedure called as print and it gives me the data that can be printed. So yeah. So this was a simple code which helped you use a data set or help you use your data step and create a data set. And we used the simple proc procedure to print it or to display the data. Now let us go further and understand few other concepts. For that I would be needing a variable say called as DOJ. It is date of joining. DOJ. Now that we've created the variable, let us give these people some date of joining, say 1901-2014. Ayushi joined say 2001 before Hemant. Ram was the first to join the office, say Ratish is fairly experienced as well, say 2011, and let us assume that Rutuja is fairly new to the office and she has joined in recently. So yeah, I've created a data set and I've given a new variable called as DOJ and I've given it few values. So let us try and print these values and see how the data looks or how the values look. Now if you take a look, the DOJ column, it's empty, it just has dots or dashes in it. Now why did that happen? Why did it not read the date which I gave it? I've mentioned it already as if there is some data which is not understood by SAS, as in it is not classified into numbers or characters, SAS won't be able to read it. So how does SAS deal with this kind of data? Well, to handle this kind of data, SAS uses a concept called as informat. Let us try and take a look at it first. Yeah, what informat does is it tells SAS how to read a variable. Depending upon the kind of format or in format you want SAS to read the data in, it has 3 types: character, numeric and data. Now the syntax is given here. A character in format is nothing but dollar, which tells that the variable is character, and W dot, which indicates the width or the length of your word that is to be entered. For numeric you have W dot D, where W indicates the number of integers that are there in your number and dot D indicates the number of integers after the decimal. And date has your fairly standard format, that is MMDDYY W dot, where W dot indicates the number of letters or integers or symbols, whatever you're using in the format. Let us go back to our problem and see what we just did, or can we do it using this in format thing. Now my data set is having a problem where DOJ is not visible to me. So what I'll do is I'll tell SAS how to read it. I'll add an in format, the name of the variable, and DDMMYY 10 dot, because I have say 8 numbers and 2 slash signs, that is 2 forward slashes. So let us try and execute this code. Now we should have the dates. Okay, wait, we still don't have the dates. We have some random numbers. Now why is that? To understand this, you need to understand SAS's date concept. dates in SAS are dealt with differently. Well, there was a SAS date counter which was started on 1st of January 1960. So the dates or the days that represent the date on this day, they are equivalent to 0. The dates that are before this number, those would be in minus values. Say 1st of January 1959 is minus 365, that is 365 days less or before this date. Then you have January 1, 1961, which is plus 366 days. And if I were to represent January 1, 2003, it would look something like 15706. So that is what I mean. As far as the date is concerned, I've used an in format and I've given in the dates, and it has displayed these dates in this format. That is the format which SAS understands, because SAS treats dates in these kind of numbers. So that is why we have that output there, where your date looks something like that, or something like this, I should say. So what can I do with it? I mean, how do I display the dates? Now, yes, my SAS has understood that it is a date and that is how it should be read, but I also need to display the dates. To do that, what we do is we use the format procedure. It is similar to in format, but in format tells you how to read the data, format tells you how to write it. So it also follows the same syntax, and it can deal with same numeric, character and date and time kind of formats. So let us try and do one thing. Let us try and implement this in a code and see if we get the dates out. Yeah. What I'll do is, below my in format, I would just add a command, say format, name of the variable, again the same syntax, and now I would try and run it and see whether I have the dates. And there you go, you have the dates finally. So that is what formats and informats do. They help you read and understand data that is normally not understood by SAS. So yeah, that is what informats and formats were meant for. We won't be using informats and formats in our future codes or the problems which we are going to deal with, but I just wanted you to know this because it's an important concept, and since SAS dates are different, I wanted you to know how to handle these things. So this was about few basics, as in how to create a data step, how to create a proc step, how to print values, how to see the results and all. I just wanted you to get an idea of all these things. I hope you understood that. Now I would be getting into something more detailed, or something more related to statistics is what I should say. I would be talking about our next problem, that is linear regression. So let us go back and get started with linear regression. For people who are new to statistics, do not worry. It's not very difficult, or it's not something that would require you a lot of logic. Let me simplify these things for you, as in what linear regression is first. Suppose I have two variables, A and B, and I need to find whether there's a relationship between these two variables. I can do it using linear regression. Or suppose I have multiple values for which represent A and multiple values which represent B, and I have new value which is for A. I need to predict a corresponding value that would be in the same block for my B variable. So how do I forecast this value? I can do it again using linear regression. Let me give you one more example. In the slide you can see that the first example is income and spending. Say for example, I have a data set where I have few income values, as in how much people earn during or in a month's phase, and I have how much do they spend in the same time. So that is given by the spending variable. So what if I say that I wanted to find out a relationship between these two variables, whether the income of a person is related to his or her spending habits, whether if the income increases, does the spending habits also increase, or does the spending value also increase, or vice versa. So to compare these things, you use linear regression. You also use linear regression to prove few facts wrong. Say for example, the second example which says student height and grades. What if I say that student grades are related to the student's height? You would say that this makes no sense, and yeah, absolutely it does not, but I need to prove it. So I can prove it using linear regression again. So the linear regression, well, the equation looks something like this. It looks like y is equal to beta 0 plus beta 1 into x. Now this beta 1 and beta 0 are coefficients which represent an intercept and a slope. These are mathematical concepts. I won't get into the details. To keep it simple, I would say that slope and intercept help you establish a relationship between x and y. So here y is your dependent variable, where y is dependent on x and your x is an independent variable. So this equation tells you that x and y are related to each other, and beta 0 and beta 1 are somehow affecting it. So if I were to take an example and I were to compare two variables, I would have to consider two possibilities. Either y and x are related or they are not related. Let us assume that our first possibility is that they are not related, and let us call it as beta 0.
sorry, H0, which is called as null hypothesis. So if my null hypothesis says that X and Y are not related, that would be based on beta 1 is equal to 0. That is what we are claiming is this value, beta 1 is 0. Let me tell you why. If beta 1 is 0, then X becomes 0. If this term becomes 0, that means Y is equal to beta 0. So Y is nothing but a horizontal line if I plot it on a graph, and its value won't change whether value of X changes or not, because it's not affecting this equation in any ways. So if beta 1 is equal to 0, then X and Y won't be related. Let us assume the second possibility where we have our alternative hypothesis, which is beta 1 is not equal to 0. In that case, it would have some value, positive or negative. So when X changes, value of Y will also change with it, because X exists, whether it's positive or negative. So that is why this beta 1 value is very important, and it actually tells you the relationship between Y and X. So let us do one thing. Let us switch to our programming mode again and try to code this out, as in see how the code works exactly. What I'll be doing now is I would be picking up a data set which I've already created. So yes, I've gone ahead and created a data set. It's a simple data set. What I've done is I've named it as practice 1. I've given it 2 inputs, X and Y, and I've given it 9 values for X and Y. So what we'll do is we'll take a look at this data first, how it looks. Yes, we have 9 observations with X and Y values with no missing values. So what we'll try and do is we'll try and draw a regression line out of these values. But before we do that, we need to develop a scatter plot. What scatter plot does is it tells you as in how the data is scattered, whether it's normally distributed or not. And if it's normally distributed, fairly distributed, we can easily draw a regression line through it. So let us quickly, for the formality's sake, take a look at a scatter plot, how the data looks. For that, I would be using another procedure called as proc. sgscatter is the name of the procedure. And again, I would be giving it the data set, which is practice 1. Yeah. So let us plot X and Y. That is done using this command. Let us see how the output looks. Okay, there was a syntax error. Okay, I made a very simple mistake. I've actually forgotten an equal to sign here. Yeah. So let us run it now. So this is how the scatter plot looks. The data is fairly distributed, and I'm sure we can draw a regression line through it and find out some relationship between these data points. Let us try and do it. Now that we've drawn a scatter plot, let us try and build a model. It is again done using a proc step. The name of the procedure is reg, and I would be again giving it the data set. The data set is practice 1, and I would model it. My dependent variable is Y, my independent variable is X, and I would be taking a confidence interval, say 95%, which is by default. I would be talking about what confidence interval is and what it does, but let us first build the model and see how it looks. Yeah, it takes a while because it's calculating a lot of values. As you can see, this simple one-liner code has given us this much amount of data. You have the fit line, you have the residual plot, you have these graphs. But I'm more interested in the ANOVA table which we have here. Let me walk you through it, what it is exactly. Now what we are trying to do is we are trying to establish a relationship between X and Y. For that we've taken a table which has 9 values. Now this is what this table gives me. It tells me that the total number of observations read were 9 and the observations that were used is also 9. So at times we might have missing values. So it would tell you that the observations used were less. Why? Because there were some missing values. The observations could not be used. So this is what this table tells you, the first table. Then you have analysis of variance table. Now it gives you various values. Say for example your sum of squares, your mean square, your F statistic, your P value for it. Now I won't get into the details as in what are these used for. To simplify things, your F test and your T test, they serve different purpose for multiple regression. But since we are using a simple linear regression, both F test and your T test would serve the same purpose. Now what do these tests do? They try and tell you whether there's a relationship between your two variables. Now how? I've talked about the thing that if beta 1's value is equal to 0, then my variables are not related to each other. And while coding, I've used one more thing, or I've talked about one more thing, that I would be having a confidence interval. Now this CLB, it gives me a confidence interval for my parameters which I'm using right now, and the confidence interval is 95%. Now let me tell you what is this 95% confidence interval first. What I'm doing is I'm taking a particular set of data. Okay, what confidence interval tells us is that my model is 95% confidence or confident that the data lies in this range or in this order. So whether there's a relationship between the two or not. So I have this confidence interval which is 95% and it has predicted parameters accordingly. If you take a look at this table, we have the intercept value and we also have the slope value, and it is in a range. It is in a particular range. Say the value might be in between 7.9 to 12.4, and for the slope it would be somewhere on -1 to -0.5. So it's giving me a range that bulk of my data, it lies in this range. That is, it is 95% confident about it, that my data lies in this range. So there's a possibility that there's 5% chance that the data does not lie here. It lies somewhere else. So if this case is true, this value, that is the p-value, would be above 0.05. I'll tell you why. My confidence interval is 95%, so I'm left with 5%. If I divide these two numbers by 100, I would be getting values like 0.95 and 0.05. So for the first condition to be true, that is beta 1 is equal to 0, this value has to be more than 0.05. So if this value is less than that value, that means my first assumption that beta 1 is equal to 0 is wrong. So let us take a look at this value first. My value is 0.0009. What does this indicate us? My alpha value is way more than this value, and that my null hypothesis which says that x and y are not related is false. My alternate hypothesis which says that there's a relationship between the two is true. So yes, I know the fact now that those two variables are related. I have these parameter estimates here which gives me my intercept value and my slope value. So if I were to go back to the equation where y is equal to beta 0 plus beta 1 into x, then I would replace beta 0 and beta 1 value with these values and I would form the equation. So yes, I have an equation and I also have a regression line. This is how it looks. It gives me a relationship between y and x. Now my value of y would decrease gradually, and there's a reason for it. The slope value here is negative. Hence the value of x, as the value of x changes, the value of y also changes and it goes down a little. That is why there's this downward graph here. And these values are not on the line. There's a reason for it. This is the closest approximation which tells you that this is how the data is related. So the little error that is there separates these points from this line, and that error can be calculated by this distance between the line and the point. So yes, we have a regression fit and it says that there's a relationship between x and y. Now what if I tell you that I had one more record where I had a value of x and I wanted to predict the value of y based on the model which I've built? Could we do it? Yes, definitely we could do it. So let us go back and try and do that now. What I'll be doing is I'll be creating one more data set. Let me call it, say, practice 2. I would go create data lines. Yeah. My input would be x and y again. So let us assume that my x value is 8.5 and I don't have a y value, so I say put a dot here maybe and I end it. Let me just print these values by the proc command. Okay, there's a small error. That is because I haven't ended this command here. Now let us do it. Yeah, but we are still not able to display the values because you do not end these lines with semicolons. You have to follow a pattern where you end it after the value which you've given. So now the data would be visible more clearly, say this way. Yes. So you have a new data set or a new data value. Now I need to add it to my existing data set which I already have. So what I'll do is I'll go back. I'll type a data set because that is what you use to manage your data. I would be wanting the value in my previous data set, so I would be giving its name first. I would be ending this so-called line. Then I would use a command called as set, and in set the data set where I want that value to be, its name, and the data set from which I want its value, that data set's name, that is to be entered. Let us print this result as well. and I run it. Yeah, so I've added a new value 8.5 and I need to predict a value for y. So how do I do it? What I'll do is I'll run a regression model on the data set which I've just updated, and I would try and predict the value. So I'll use the reg function again. I would give it the data and I would build a model for it by saying y is equal to x, and this time I would be using CLI because I want confidence interval for the records I've entered and not the parameters. So this is what I would be doing, and then I would be running the model on it. Let us see how the result looks.
And there you go. You have all the statistics again. But if you've noticed the change here, we have 10 observations and one has missing value, the one which we are trying to predict. We have previous statistics as in the p-value for T and F tests, but we are more interested in the prediction part right now. So let us quickly go to that table. We have output statistics here. Now you can see that we've calculated a 95% confidence interval for all the variables, but we are more interested in this value, the missing value of dependent variable, that is your y value. Now we have our x value which is 8.5 for it, and we also have the model that is which we built based on the 9 values which we had. So based on that model and the value for x which is 8.5, my model is 95% confident that value of y should be in the range of minus 1.37 to 5.37. So yes, using linear regression in SAS, what we have done is we predicted the value of y here, and that is what our aim was. So this was a very basic problem, but I hope you've grasped few things as in how to do basic linear regression operations and how SAS works and the coding part works. So this was for the programming concept, and I'd be ending the programming part here, and I would be moving to the next part of the session, that is SAS applications. Yeah, so SAS has quite a few applications. I've mentioned few here. I would be talking about stock prediction. Now, stock prediction is something that is very time dependent, as in the values or the stock prices, those vary from time to time. And to deal with these kinds of problems, we use time series. And that can be done in SAS by using a component called as SAS ETS, which is very useful for time series analysis. Now using that you can predict stock values, or as in you can predict how a particular stock is going to behave in near future. So yes, SAS does help in stock prediction. The next point is creating safe drugs. Now SAS is one of the important tools when it comes to medical analytics. It has various applications when it comes to a prescription drug or prescribing drugs, I should say, to different customers. Those problems can be solved by using SAS. It recently helped detect cancer or solve cancer problems using analysis. Now that was an achievement. So yes, it has a great market as far as dealing with drug problems or creating safe drugs is concerned, or safe medicines is concerned. Then fighting fraud. HSBC is one of the important clients as far as fraud detection is concerned, and what they do is they use the SAS technology to develop their real-time applications, like detecting fraud in real time when it comes to dealing with credit card frauds or debit card frauds. And they're actually planning to take this technology further, and they're still collaborated with SAS and they're working on those projects right now. So yes, SAS does help fight fraud as well. Then optimizing workflow. Now this is a very important problem. Normally most of the businesses have this problem. They have a lot of traffic and they have to manage that traffic or have to manage their workflows. Now optimizing these workflows becomes very difficult, and as SAS is a fourth generation programming language, it can be built in such a way or used in such a way that it can solve these problems which are specific to organizations, and it helps optimize various workflows. So that is one of the applications. So this was about SAS applications, and this was the final topic of our today's session. I hope you've understood whatever I talked about till time. Let me just quickly walk you through as in what all we've talked today. We started things off with data analytics as in why it is needed and what it is. Then we discussed few data analytical tools. Then we got into SAS as in why it is needed, what it is, and we discussed its framework as well. I introduced you to few SAS programming concepts like the basic building structure or the building blocks of SAS programming. I also talked about how data is handled, what are the different formats of data, and how formats in formats and SAS dates work. Then we got into statistics and we took a look at a simple statistical procedure called as linear regression, and we tried and predicted a value based on the model which we built.
And finally, we talked about SAS applications. So this was about SAS, and I hope that you've understood whatever I talked about. But if you still have any doubts, you can post those questions in the comment section below, and I promise you that I would be getting back on those questions with my answers as soon as possible. So, and if you're interested in knowing more about SAS, you can always turn to our website, that is Edureka, and you can take a look at our SAS training programs. I'm sure that would help you get in-depth knowledge about SAS and help you pursue a career if you are interested in pursuing a career in SAS. So that was on my part, or that is something I wanted to talk about. I hope you've enjoyed today's session, and I hope you would be wanting to hear from me in near future as well. Thank you. Bye-bye.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!